Okay, so our last Loom video was referred to as the old brain, and that's because those are basically our survival functions if you think about them. Um, all of them are pretty much what we need in order to, survive the day, the week, the month, etc. The new brain um, is more about what separates us from lower forms of life, what separates us from each other, what allows us to think. It's the part of the brain that continues to evolve, that continues to get better um, as we go through thousands and thousands of generations. So my circle they keep making the circle bigger. I don't like it, but we'll make adjustments. So the new brain is mostly referred to as the cerebral cortex, sometimes the cerebrum. So don't get confused when you see those words. And the cerebral cortex is, again, I'll kind of repeat that, but we'll get it written down. It's the part of the brain that provides us with the ability to think, physically feel, move, hear, see, and it's what separates us from lower forms of life as well as one another. Okay, and there are 4 lobes in the cerebral cortex. Okay, there's 4 lobes on the right hemisphere, like you're seeing here, and there's 4 lobes on the left hemisphere as well. The biggest of those 4 lobes is referred to as the frontal lobe. Okay, and the frontal lobe is responsible for our ability to think, to plan, to organize, as well as to move and to speak. Also our personality, you probably want to throw that in there as well. So it's a really, really important, obviously, structure of our brain. It's, again, probably where most of our not only our personality, but our thinking is found. We have 3 parts of the frontal lobe that we need to know. Okay, I'm going to move myself up here. Okay, so first of all, we have the prefrontal cortex, which is kind of this area, this green area in the front. So again, this would be the right hemisphere because it's facing this way, and this one on the bottom would be the left hemisphere. So this green area here is referred to as the prefrontal cortex, and the prefrontal cortex is the part of our brain that is responsible for decision making, planning, and impulse control. Okay, so when we talk about impulse control, we talked last video about my dog's Oscar's bugging me. Stop it. We talked in our last video about the amygdala, right, and how the amygdala is responsible for primal emotions of fear and anger. And if you've ever acted out of anger, where you regretted it almost immediately after you did it, you said something you probably shouldn't have said, or you threw your remote control at your brother, or something like that, or you broke something out of anger, that's a combination of your amygdala being activated, and it's also your prefrontal cortex not being developed enough to control the amygdala. So this prefrontal cortex piece helps us to do that. Okay, it also helps us to look at long-term goals and again make decisions that are in line with those and that type of thing. Now, another interesting thing about the prefrontal cortex is it's the last part of the human brain to develop. Again, so it's in this area, it's in this very front. Okay, and so it's really in you guys. It could be still open because the prefrontal cortex remains open until about 24 years old. And that's, really important to understand, because when you look at the behavior of some, people, teenagers, for example, a lot of times adults are confused by their behavior, don't understand it. What were you thinking? That type of thing. And the real explanation is that this prefrontal cortex piece isn't fully developed. It's part of the reason that there is an age thing in terms of committing crimes are you tried as a juvenile or as an adult, and that type of thing. I mean, brain research, really tells us that, being an adult probably doesn't happen at 18 in terms of our ability to think. It's more, again, in the early 20s. Okay. We'll be talking about the prefrontal cortex all year long. So the Broca's area is this purple area here in the frontal lobe. If you were to make like a size of a quarter circle and put it on your temple on your left side, though, that's important to understand, is that Broca's area is only in the left hemisphere. And that's all of your ability to speak. So everything that I'm doing right now is coming from my Broca's area. Okay. And remember that in Spanish, mouth means boca, or vice versa. So think boca, broca. That'll help you to remember that that's where the speech is formed. If there's damage to Broca's area, then the person will not be able to speak clearly. Okay. Motor cortex is this red strip. It's in the back of the frontal lobe, and it's responsible for all of our movement. So your entire body, any part of your body's movement is found in that strip somewhere, and then there'll be more on that later. And we go to the next slide. So we'll go multiple choice question here. Okay, our next lobe is the parietal lobe. The parietal lobe is behind the frontal lobe, above this temporal lobe, and in front of the occipital lobe. It's this pinkish area here, and this one down here, again, this one's the left hemisphere. That's more the blue area. And the parietal lobe is responsible for processing temperature. It's also responsible for touch, the sense of touch in particular. Okay, and visual spatial abilities. Okay, so visual, spatial, touch, and temperature. The area, this strip right here, is called the somatosensory cortex, and it's located at the front of the parietal lobe. Remember, the motor cortex is located in the back of the frontal lobe, and they're right next to each other. And again, this makes perfect sense because if, let's say you're with a friend and you're just friends, right? You're just friends, and you're at a movie or something, but that friend wants to be more than friends and you don't, and that friend reaches over and touches your hand to kind of make a move. You feel that sense of touch, and if you don't want to be that, you pull the hand away immediately, right? Because these two are right next to each other. So it's important to have movement next to touch. If they were on different sides of the brain, then that would not be as efficient. Again, the brain is amazing how it's laid out. Speaking of laid out, what's really interesting also is how the motor cortex and the somatosensory cortex are laid out. So this is the somatosensory cortex. This is the part of the brain that's responsible for touch. This is the motor cortex. This is the part of the brain that's responsible for movement. And you can see that it's not laid out, head to toe necessarily, that it's laid out differently. So the top of your somatosensory cortex would be where your toes are, basically, and it would roll all the way down. Okay. With your face more near the middle part of it. So probably more in this area. Okay. You also notice that the way they laid this out, you'll see that the thumb, for example, is bigger than these other fingers, and that's because your thumb has more sensory neurons in the sensory cortex, somatosensory cortex. So it's a little bit more sensitive to touch. And you notice how big the lips are here. That's because our lips are arguably the most sensitive part of our body. And that's because there are more neurons in the sensory cortex dedicated to it. So if we were to measure this out, you can see how much of this blue area is, given to the lips versus, say, the elbow, which is right, just a little area here. Okay. If we were to lay this out in terms of a person, and this is kind of a weird looking dude, but if you look at a guy named Homunculus, okay, this was how we would look if our body were sized according to our sensory cortex. Okay, so you would see how big our hands are, or would be, and that's because, again, our sensory cortex is dedicated, a lot of it is dedicated to the hand and the foot and the lips, okay? And this is why, if you're looking at something that looks really smooth, or you're just curious about how it feels, you reach out and touch it with your hands. You don't like rub it with your elbow because you won't get the same sense of touch out of that, okay? Okay, don't want to cancel. Okay, wait. All right, we're good. I realized why the slide thing works the way it does. I figured something out in this video. Okay, so next is our temporal lobe. Our temporal lobe is this green area here. Our temporal lobe is responsible for recognizing sound. It's where our auditory cortex is located. It makes sense, auditory sound, right? So if you are walking across the street and you hear a horn and tires screeching, your brain processes that and knows immediately that that's a car and that you should get out of the way. If you don't know the sound, if you don't know what that sound is, that would be really, really confusing, and you could get hit. So recognizing sound is really important in order to respond to the sound. Within the temporal lobe, we have this pink area here called Wernicke's area. Okay, and Wernicke's area, again, if you take that little circle and put it above your ear, is responsible for recognizing speech. Okay, just speech. So if you have damage to that area, you might be able to talk if Broca's area is fine, but you will not be able to understand speech. So I read a story once about a guy who had real mild stroke in his Wernicke's area, and he only lost the ability to understand verbs. So he could understand everything except verbs. So if you said, Jenny spilled the milk, it would come out, Jenny the milk. And so the person didn't know if Jenny drank the milk, threw the milk, spilled the milk, or what. So it was really interesting. It helps us to understand that we have specific neurons or neural networks in our brain just for certain parts of speech. And this was true when he tried to read too. If he tried to read, any verb to him didn't make any sense. It was like blurry. So really, really interesting stuff about the brain in general. Okay, so random multiple choice question for you. Another one. And let's talk about the occipital lobe, which is the fourth of our four lobes. The occipital lobe is located in the back of the brain. Okay, so it's back here. And it's also where our visual cortex is. And the occipital lobe is responsible for recognizing what we see. Okay, our eyes get way too much credit. Our eyes, not only do our eyes see very poorly, but they also don't understand what they say. They just see. Our brain takes the information and makes sense of it. So for example, this picture is what your brain sees, but this picture is what your eye sees. So when your eye looks at an object, it's upside down. All right. It's full of these red lines from your blood vessels. It has blotches all over it. It's much more blurry than the original picture. Your brain takes that image and flips it so that it looks like it's supposed to look. Okay. In fact, some psychologists made goggles that people volunteered to wear, an experiment, and it flipped the world upside down. So these goggles made everything look like it was upside down. And after a certain amount of time, the brain realized this isn't the way it's supposed to be. And the brain actually took that image and made it right side up. So these people were wearing upside down goggles, but the world was right side up. When they took the goggles off, the world flipped upside down. So without the goggles, everything looked like it was upside down. And then after a while, again, not too long, the brain realized this isn't the way things are supposed to be and flipped it right side up. Okay. So again, brain, you can't even put into words how impactful the brain is. Finally, I want to talk about association areas. And association areas run all through the cerebral cortex. Okay. So we'll start with that. They run all over the cerebral cortex, and they are responsible for learning, memory, and thought that we don't quite fully understand yet. Okay, so we're just beginning to understand association areas. So when I say, for example, tell me about a really powerful memory that you had from when you were younger and what you learned from that memory, your whole brain would be firing, because your occipital lobe would be picturing what happened. Your frontal lobe would try to be making connections. What do I learn from that? You have memory centers all throughout the brain. So your whole brain would be operating. So if we had you in an fMRI machine, which you'll learn about later in this unit, it would just be flashing all over the place. So that's what association areas are. We have a multiple choice question.